this is the model that we built in Module 5. And what we're gonna do in Module 6 will be very similar to the formulation we learned in Module 5. But before we begin, let's just run the Module 5 base in case you don't have it loaded on your model. So what we're gonna do is we're gonna go and do sim setup, and then we're gonna run the model. Okay? All right, so what we're gonna do is we're gonna create a variable that's very, very similar to the effective death rate on number of contacts. So we're gonna click variable, and we're gonna name this effect of death rate on infectivity. Okay. Now, just like F1, we're gonna have another table function, and let's call that F2. Okay. So we have F1 affecting, let me just relocate this, effective death rate on number of contacts, and F2 will define the effective death rate on infectivity. So the input of this table function would be ratio of perceived death rate to death rate threshold. So you want to create that link. Okay. And then this will have an impact on the infectivity. Okay. As you can see, infectivity is currently defined as 0.05. However, what we're going to do is we're going to actually create the normal infectivity, which is kind of similar to the idea of normal contacts per day, which we have multiplied to the effective death rate on number of contacts. So in similar way, we're going to create a variable, normal infectivity, and we're going to set that as a 0.05. Okay, so infectivity will be normal infectivity multiplied by effective death rate on infectivity. Okay, so that's what's gonna be for our Module 6 formulation. What I'm gonna do is I'm gonna move around my variables a little bit so that they overlap less, and it's easier to see. When you grab these little handles on the arrow, you can change the shape of your arrow. And what I'm gonna do is I'm gonna move this little bit towards the side. Okay, so that my infectivity is down here. Okay. All right, I'm just trying to, it doesn't really, you don't have to worry about making it look pretty or anything, but you want to make sure that it is, displayed in a way that's easy for you to keep track of or understand. So I do care about where I put my variables. Okay, so I think it looks good. Okay, now let's define the equations. So first of all, if you look at Ali's model, the table function he used to define the effective death rate on number of contacts and effective death rate on infectivity, they are actually looks the same. Okay, so what I'm gonna do is I'm gonna actually go and click F1, which shows this graph, right? I'm gonna copy it into F2. So you can just click OK, and this is what we want to copy here. Okay, so in the equation box, I'm gonna go and select everything, and I'm gonna copy this, click OK, and then come out to F2. All right, now you have to first change the type, which is lookup. Okay, and then I'm gonna paste what I have copied into the equation box. All right, and then unit is a dimensionless, DMNL. If you click S graph, you will now see the same graph here. Okay, so it goes from input of 0 all the way to 128, which represents the ratio of perceived death rate to the death rate threshold. So if this is 1, that means the perceived death rate is same as the threshold that we set. So in that case, it would have the output of 1, which when we multiply that to the infectivity, it's not going to do anything to the normal infectivity, right? However, if the death rate, the perceived death rate starts to go above the death rate threshold, what happens is our output falls below 1. And when we multiply that to the normal infectivity, then the infectivity will actually start going down, which represents various safety measures or behaviors that we can adapt when things get really serious. Okay, now the effective death rate on infectivity will be F2, and then you open parenthesis, and then you're going to put your input, which is the ratio, close the parenthesis, and then your unit's going to be dimensionless. Okay, now the normal infectivity, we're going to set it as 0.05, and then the unit's going to be 1 over contacts, and then the infectivity. Now you have to delete this in the equation box, because now it's going to be normal infectivity multiplied by effective death rate on infectivity. Click OK, and now we are done. Now please save your model as module 6. Okay, so now let's run module 6 base. Go to sim setup, and then you're gonna change it to module 6 base and simulate. Okay, now we can compare the module 5 and module 6 behavior. So if we go and take a look at the infected asymptomatic population, so this is module 5 and module 6, because now people's behavior is changing as well as people's number of contacts. Now the people are responding to the death rate, and now the extent of people getting infected is much smaller. You can see the same trend here. If you look at the incidence rate, this is how things are different from module 5 to module 6. Now let's take a look at the cumulative death. Okay, so we will end up with a much less number of deaths in module 6. Okay. If you go to the control panel, to the graphs, we have a lot of graphs that we have created. Behavior of stocks, if you go and check that out. Okay, we have all these stocks in the graph. Let's just change the title to module 6, behavior of stocks. And then if we display, this is what it looks like. Okay, so some of them are in the same scale, others are not. Okay, however, if you take a look at this, this is what's going on with the susceptible population. So you start seeing all these waves, right? If you look at the infected asymptomatic population, which is the red line, and infected symptomatic population, which is the green line, it's very, very clear that there is these waves of people infected with virus. Okay, and the black line is the cumulative death. Okay, and then it jumps and then it stabilizes, it jumps and stabilizes. It is showing waves as well. This is the flow of people, which represents all these inflows and outflows between the stocks. And the incident rate, that's the new number of people contracting the COVID. As you can see, the first wave, it's really, really high. But then after the second wave, third wave, we are adjusting our behavior based on the death rate, and we kind of lower the number of incidence rate. However, number of people get infected with COVID. However, we don't completely get rid of the infection. It still comes back in waves. Okay. Comparison of behaviors. I think we do need to modify this. So we're going to modify so that it's module 5 compared to module 6. Okay. And then here the data set, let's just change it to 5 and 6 incidence rate. And then cumulative death, we are comparing module 5 with module 6. Okay, click OK. And then let's display this. Okay, so with incidence rate, we are comparing this blue line with the red line. So things look much better with the red line. And then cumulative death, okay, this is the module 5 and this is module 6. So when we are activating the balancing loop from the death rate to the incident rate, there are two balancing loops, one through the number of contacts and the other one through the infectivity. Okay, when these two balancing loops are active, then the incident rate will be much lower than the model where we don't have these two balancing loops.